Today, we delve into the pinnacle of calculus as we demystify optimization problems. Consider the following problem. From a log of wood that has a circular section with a radius of 3 decimeters, it is required to obtain a rectangular section plank. What dimension should the rectangle have if we want it to have maximum area? Let x, h, and a be the base, height, and area of the rectangle, respectively. Then a is equal to x times h. Now, we can express h in terms of x by considering the right triangle with hypotenuse 6 decimeters and base x and height h. Then, by using the Pythagorean theorem, we have that 6 squared is equal to x squared plus h squared. And by solving for h, we have that h is equal to the square root of 6 squared minus x squared. Thus, h is the square root of 36 minus x squared. Therefore, we can express the area in terms of x as a equal to x times the square root of 36 minus x squared. First of all, notice how x has to be between 0 and 6 in order to have a of x properly defined. Now, the problem consists on maximizing the area. Thus, we need to find the maximum of the function a of x by applying the derivative to this function and finding the critical points. If we apply the derivative to this function, simplify, we get the following result, which critical points are -3 square root of 2, 3 square root of 2, and 6. But we have to discard -3 square root of 2 because this is a value of x and x is a measure. Thus, this value has to be positive. Now, let us compare the following results. A of 0 is equal 0. A of 3 square root of 2 is equal 18. And a of 6 is equal 0. Thus, the maximum area is reached when x is equal 3 square root of 2 and h is also 3 square root of 2 after substitution. The previous example is just a tiny bit of what you can do with derivatives. Everything that surrounds us depends in one way or another on the concept of change. The world is constantly changing, and thus it can be improved by means of differentiation, and you can be the one who can make a difference.